Hello viewer and welcome to the e-learning classroom. So today we want to know how to determine the refractive index of the glass block. How to determine the refractive index of the glass block using the ratio of sine I and sine R. So we are going to, first of all, we are going to mount the plain paper. We have the plain paper here. So we'll first mount the plain paper on the soft board. So we first mount the plain paper on the soft board using the office pins. We have the office pins here. We mount the plain paper on the soft board. That is the first step. We have mounted the plain paper on the soft board using the office pin. Once we are done that, now we place we place the block, that is the glass block, on the soft board, and then we trace the outline of the glass block. So we place the glass block gently, somewhere almost in the middle, and then we trace the outline of the glass block. You have to ensure the glass block is rigid on the soft board to ensure it doesn't move as you trace. So we are tracing now the glass block. So we are done. Once we are done tracing, we can remove the glass block. This is what we have, the outline of the glass block. So, and once we are done with that now, we draw the normal line somewhere close to the middle. We are going to draw the normal line on the outline, and the first thing, maybe we can mark a point, just as a point on the, can mark a point on the outline. We are going to use this point to draw the normal line. So we have to ensure we have 90 degrees through that point. We have to ensure we have 90 degrees there, and then we join the 90 degrees to obtain the normal line. So we now have the normal line that is cutting the outline at 90 degrees. We have the normal line there. So with that now, because we are going to consider several angles, we are going to consider several angles. The angles will range from 20 degrees all the way to, the angles we are going to use is 20 degrees all the way to 70 degrees. Maybe you can mark those angles. Maybe you can mark those angles. So we'll start with the 20 degrees, 30 degrees, 40 degrees, 50 degrees, 60 degrees, and then 70 degrees. These are the angles we'll be plotting with. We have the angles of this of incidence, then we have angle of reflection, then we have sine I and sine R. So what we do now, let's maybe we can mark those angles. We can mark those angles here. Let's say we are marking the 6 angles. So remember, all angles are measured from the normal, so you have to place your protractor like this so that you have 0 at the normal line. At the normal line, you should be having angle 0. And then you measure the angles. Maybe I can start with I can mark the angles 20, 30, 40, 50, 60, and 70. So I have marked the angles. I have marked the angles there. Let me first draw the first angle, the angle 20. Let me draw first the angle 20. Let me mark this point here, that joint. So the angle 20 these are the angles of incidence. So I've drawn the line along the angle 20. So what I do, I can place 2 pins along that line. Can place 2 pins along that line. The 2 pins should not be very close to each other. I have 2 pins not very close to each other. And then with those 2 pins, I replace back there. I can replace back the glass block. Can replace back the glass block. So that we see now how the 2 pins will be appearing. Let's adjust this. Let's adjust this so that you can see what we are doing here. I want you to understand exactly what we are doing. So with those 2 pins, I look through the glass block to place 2 more pins such that the 4 pins are forming one straight line. So I can look through this side to trace the 2 pins. Let me trace these 2 pins. You have to ensure that the pins are forming one straight line. Maybe you can see what we have there now. You can see the pins forming one very straight line. Look at them. We have 4 pins, but our interest is to ensure that they are forming one straight line. So we are ensuring they are in one very straight line, such that when you look at the images, you are only seeing one pin. So with that, I can now remove the pins I have mounted, and also the glass block. Can remove the 4 pins and the glass block, and then what I do, I join the 2 holes again. So after removing the glass block, I now join these 2 pins, the holes I have made. I join these 2 holes I have made here. With the outline of the glass block. You can see that I have joined the 2 holes. And after that, now what I do, here I can mark this point. So after that, what I do now, I join these 2 points. I have this point and this other point. So I have joined them like that. You can see that. This angle here is now the angle of refraction. So let me measure this angle now. All angles are measured from the normal. So you have to place your protractor like this, so that the normal should be in line with the baseline. So let's see what we have for this angle. So this angle here is 13. The angle is 13. So I can record it. I can record it here. The angle is 13 degrees. The angle is 13 degrees there. I've recorded the angle. So we have the angle there 13 degrees. The angle 13 degrees. So we do the same now for the other angles. Let's say I now go to the angle 30 degrees. Maybe I can use a different color for 30 degrees. Remember, you have already marked the angles. Let me now connect angle 30. Can use a red pen for the angle 30. So let's see. So I've connected 30 degrees. We already measured those angles before. And then what I do, I place 2 pins again. I press back the 2 pins. The 2 pins back there along that line. You have the 2 pins there. From there I also replace the glass block. Let's see. Replace back the glass block again. So once the glass block is in place now, I have confirmed. Once the glass block is in place, we look through this side to see the two pins forming one line. So I place two more pins. The two pins I'm placing should not be very close to each other. The pins I am placing should be forming one straight line. Maybe you can observe that. Let's see whether we can see that. What we have done there. So we have the two pins there. So let's see. If you look through here, should only be seeing one pin. The other three pins should be in one line. You can see that. Look at the four pins. But now when you look at them, you realize they are forming one straight line, such that you can only see one pin, the images. So from there now, what we do, from there now again we remove the pins. We remove the pins and also the glass block. So maybe then from there we join these two holes. We join these two holes. They can mark this point. Once you have joined them, let's see now, this one I can join them here. Can join this point and this point. Let me also adjust this one so that it seems. So I'm joined those 2 points. You can see that. So I can now measure the angle of refraction. Can now measure the angle of refraction here. Can now measure the angle of refraction. So the angle is 20. The angle is 20 degrees. So I record 20 degrees. I've recorded the angle there. 20 degrees. So from there now, we proceed with the next one now. Maybe I can now join the other angle, which is 40. Can now join the other angle, which is 40 degrees. The angle 40 degrees. You have the angle 40. I place my 2 pins. I place my 2 pins. And then I also replace back the glass block. Can also replace back the glass block. After placing the 2 pins, you have to confirm every side. I have replaced back the glass block. Then again I look through this side so that I place 2 more pins such that they are forming one straight line. So I look through this side. You must ensure that the pins are forming one straight line. Maybe you can confirm that. If we're able to see that, let's see. Look at the 4 pins. Look at those 4 pins. The images, but now you adjust. Until they are forming like one pin. So from there now, so again now we remove the pins and join the points. After removing the pins, we join the points. We join these points with one straight line. We can mark this point here. And then again I join this point and this other point. So I've joined the 2 points. We measure the angle of refraction. The angle of refraction there. So the angle is 26. The angle there is 26 degrees. So I record there 26 degrees. Recording the angle there 26 degrees. We proceed now to the next one. The next one is 50 degrees. Again, I join 50 degrees. I have already marked all the angles. So I join 50 degrees. Then I place 2 pins. I place 2 pins. And then replace back the glass block. I'll place back the glass block, and then through this side I look for the point where the pins are forming one straight line. So I search the pin, I have searched the pins. Let me show you. Let's see whether we are able to see that. Look at the 4 pins. Look at these 4 pins. When you adjust them until now, they are like this. You can only see 1 pin there, meaning the 4 pins are in one straight line. So from there now, I remove the pins and also the glass block. I remove the pins and the glass block. Then I can join the two. Holes. I can join the 2 holes. After joining the 2 holes, now I join again these points. I join those 2 points like that. You can see the diagram is taking shape. So let's measure that angle now, the angle of reflection. So the angle there is 30. So the angle there is 30 degrees. So I record here 30 degrees. I record here 30 degrees. We go to 60. 60 degrees. Again, we join the points. We make the angle of 60. We have the angle of 60. Then we place the pins. 2 pins. Then we'll place the glass block again. So after replacing the glass block, now we look for the other 2 pins through this other side. We look now for the other 2 pins through this side now. So that is the point now. Maybe you can see that. We can see that. Can see the 4 pins forming one straight line. The 4 pins forming one straight line. So from there now, we remove the pins and also the glass block, and then we join those 2 holes. We join those 2 holes. We can mark this point. So after joining those 2 holes, we also join these 2 points. So we have also joined those other 2 points. From there we measure now the angle of reflection R. The angle of reflection R so that angle is 37. So the angle is 37. So we record here 37 degrees. Lastly, we go to 70 degrees. You have that 7 degrees here. Lastly, we go to 70 degrees. So we measure we join the angle for 70. We had already measured the angles. So we have 70 degrees here. Once we have measured 70, we place 2 pins. We place 2 pins there. And then we replace back the glass block. So after replacing back the glass block, we can now check through this side to search for the 2 pins. So maybe you can see that. You can see the 4 pins. So let's see that. Look at the 4 pins. forming one straight line. The 4 pins are forming one straight line. So from there we remove the 4 pins together with the glass block, and then we can join these 2 points. Can join these 2 points now. Maybe we can also mark this point. And then we join these 2 points again. And then we measure that angle, the angle of reflection. So that angle is 39. That angle is 39. So we record here 39 degrees, 39 degrees like that. So that marks the end of part 1. Let's look at the computation. So let's look at now the computation. So we have sine I. So that means we have sine 20, which gives us 0.3420. Sine 30, sine 30, 0.5, maybe we can add 3 zeros. Sine 40, sine 40, 0.6428. Sine 50, 0.7660. Sine 60, 0.8660. Sine 70, 0.9397. Let's go to sine R. We start with the sine 13. Sine 13, 0.2250. We go to sine 20. Sine 20, 0.3420. We go to sine 26, 0.4384. We go to sine 0.766. Oh no, sine 30. Sine 30 is 0.5. maybe you can add 3 zeros, sine 37, 0.6018. Then we have sine 39, 0.6293. So those are the values of sine. Those are the values of sines. And then with this now, we are now plotting a graph of sine I against sine R. So we are now plot a graph of sine I against sine R. Plot a graph of sine I against sine R. So the first thing, with our graph paper, we have the graph paper here. So the first thing is to draw the axis. So we draw the axis on the graph paper. Maybe we can draw on the first square. Draw the axis maybe on the first square. We have the axis. The axis must have arrows. And then with that, we can label this side sine I, and this side sine R. Sine I, and then we have sine R. Then we have to ask ourselves, on the side of sine I, the largest value is 0.9, and also on the side of sine R, the largest value is 0.6. So for sine I, we are going up to 0.9. So let's say we have two squares. We write 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, let's say last three, 1.0. Two squares here are representing 0.1. For the other axis, we are going up to 0.6. So let's say we also have two squares, 0.1. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, maybe up to 0.8. So we have the axis like that. We have the axis. So what we do, we are plotting the first one, sine I. Let's say we have sine R 0.23. We can load off 0.23, 0.34, 0.23, 0.23, or maybe you can say 0.23 and half, all the way to 0.34, all the way to 0.34, 3, 4, somewhere here. We have marked the first point, somewhere there. We go to the next one. The next one we have 0.34. Then we rise to 0.5. 0.34 all the way to 0.5. That is that point. The next one is 0.43. 0.4338 all the way to 0.64. 43 we rise 43 we rise up to 0.64. 64, that is somewhere here. This is 438, so somewhere here. Then we go to the next one, 0.5. We rise all the way to 0.766. 766. Somewhere there. Then 0.60. We rise all the way to 0.86. 0.866. That is a point. Then lastly we go to 0.63. So that is 63. We rise all the way to 0.94. All the way to 0.94. 63 all the way to 0.994. 94 is somewhere here. 94. So it's somewhere here. Those are the points. Those are the points we have been able to mark. And then we join these points now. We join these points with a straight line. We join these points with a straight line. That is the line of best fit. So that is the line of best fit with all the points who are well plotted. That is the line of best fit. So with this line now, we find the gradient by picking two readable points. So we select two readable points. So maybe we can pick, let's say we pick this point here. At the other point, let's say we pick another readable point. Let's say we pick this point here. So let's draw the line for the slope. Let's mark the points that we are using to find the slope. We are using these 2 points to find the slope. So we want to see what the slope becomes there. And then, so we can also read this other point. So this one is 0.5, 0.5. The other side is 0.7, 0.07, sorry, 0.07. Even this one is also 0.05, 0.05, 0.07, 0.05, 0.07. This one is 0.07. This one is 0.05. So with that now, we can determine the slope of this graph. So we can determine the slope of this graph. We know, first of all, we know slope is equal to, in mathematics we say slope is change in y against change in x. That means for this particular case, our y is sine I and our x is sine r. So it will be change in sine I divided by change in sine r. Of course, you know sine I over sine r represents the refractive index. So that means slope is equal to change in sine I. So we have these 2 points here, 0.95 minus 0.07 divided by 0.65 minus 0.05. So slope is equal to, let's see, 0.95 minus 0.07, then divided by 0.65 minus 0.05, and this one gives us 1.467. So in other words, we know slope represents the refractive index, because slope is sine I, change in sine I over sine r. We ignore the change, sine I over sine r, which is the refractive index. And that means, since slope represents the refractive index n is the refractive index, then that means the refractive index n of the glass prism we have used is 1.467. Remember, refractive index has no units because it is a ratio of sine I to sine r. So those are the values, dear viewers. You can see what we have now there. Those are the various values and the refractive index.